All right, so next one, I'm sorry, this one here. It's asking you to basically take a look at these two things and match them up down here. So in this one, C's under B only, and in this one, C's under both of them. So it tells you to enter A and B for the first two, so it'll give you the first two. And then the next one, C's under both of them because of these parentheses, so that's B. And then the next one, C's only under B, so that's A. And then this one, C's only under B again, so that's A as well. All right, this one's a little harder. It asks you to rationalize the denominator. So in order to rationalize the denominator, you're going to want to multiply the top and the bottom by what's in the denominator, but change the sign. And we're going to do that throughout the course of the year. Anytime we rationalize the denominator, and we'll do it with complex numbers as well, to get rid of complex numbers in the denominator. So you just multiply by the very same thing, except for a different sign. And top and bottom, because that way you're really multiplying by 1, and it doesn't change the value of the expression in it at all. Okay, so in the top you're going to have 11x square root of 5 plus 2y square root of 3, and then at the bottom you're going to have to FOIL this. So first times first, you'll have 11 times 11, and then you'll have x times x, which is x squared, square root of 5 times square root of 5, which is 5. And I'll simplify this in a second. The middle terms are going to cancel, so you never worry about the middle terms. So then it's just last times last, which gives you negative 4y squared times 3. And then we can simplify this a little bit, hopefully. Let's see, 11x squared root of 5 plus 2y squared root of 3 all over 605 x squared minus 12y squared. And it must be what they want us to enter in for A and B, because I don't see anything that simplifies from here. Yeah, so this is a tough problem. This is what it wants us to enter in, and this is really hard to enter in. This is one of the bad things about Webwork. We have to enter that in for A, and we have to enter that in for B. So here's how I entered it in: 11x, and then parenthesis square root sqrt, and then another parenthesis 5, like that. That's how Webwork wants you to enter in the square root, which is a pain, but you know, that's the only way we have to do it right now. So the numerator is A, and the denominator here is B. I know you'll have different numbers probably, but hopefully you can get that entered in. Next question wants us to solve for h, so we did last year quite a bit. To do this, I'd multiply both sides by 3. That way you have 3v equals pi r squared times h. We're solving this for h, so let's divide both sides by pi and by r squared. And we're done. H equals 3v over pi r squared. And this is a little tricky as well because Webwork wants you to use pi for pi. So when you enter this in, you're going to use pi right here. And then in this r squared right here, you're going to have to use that caret sign too. A little sloppy, but you get the idea. That will be the right answer then. So take a look at it when it's entered in. Webwork's really picky. Like, you have to have a capital V here because that's a capital V, and you got to use pi. You don't have to use the multiplication symbol in here. I think you can if you do like shift whatever it is on your keyboard. It'll accept that as well. But it is picky. You have to use parentheses over the numerator and denominator as well in this case, because otherwise, if you don't, if you enter it in like this, for example, then what's going to do is it's going to divide this number right here, which is a number. It's going to divide just into V and not into 3. We'll talk about that throughout the whole year too, because our calculator does the same thing. You need to make sure you put parentheses, so you're saying you're dividing this whole thing. You're dividing this whole quantity by the denominator. All right, so the next problem wants us to solve this equation. We're going to do this quite a bit this year where we're solving equations with fractions. Anytime we do this, you can clear fractions if you want by multiplying through by the least common denominator. So we'll talk about that a lot. It's called clearing fractions. So multiply through by the smallest thing that both 5, 2, and 6 go into, which in this case is 30. So if you multiply through by 30, what happens is 5 goes into 30 6 times. 2 goes into 30 15 times. and 6 goes into 35, yeah, 5 times. So what you're left with then is 6 times x plus 15 equals 5x. So that's a quick way to just make the fraction or the equation a lot more simple. All right, so then we can solve this. So I'll just subtract 6x, and it gives me 15 equals negative x. So x equals negative 15. All right, this is something that we're going to learn this year. You're going to have to know how to use interval notation. Most of the time you've used, I think, inequality notation in the past. So interval notation, this means we're going from negative infinity all the way up to 0. And you never include infinity because you can't technically include that in your set. And then we are including 0 in this case. So it wants us to do inequality. So the same thing would be, let me do it here. Same thing would be x is greater than, or x is less than or equal to 0. That's saying we're including 0, but we want all the numbers that are less than 0, which is exactly what this is saying. If you looked at a graph of this, then this would just be at 0, we're including 0, and then we're going to go all the way to the left. So we're including all the numbers to the left, all the way down to negative infinity. So these all mean the same thing. Here's a interval notation. Here's inequality notation, and then here is a graph, line graph. So let's say x is less than or equal to 0 here. And I know this is weird as well, but in Webwork you have to do less than or equal to like that. So like do the less than sign on your computer and equal to on your keyboard, and that means less than or equal to.